So, I am a little bit, partial to these spheres. Okay, so this is 12.6. 12.6 is on surface area and volume of spheres. We're just going to do surface area now. Tuesday, you're going to have a quiz on all the surface area. That's 2.5 lessons. And then we're going to move on to volume. So we're going to revisit 12.6 later. Okay. So, this is a picture of a sphere, right? And the way we like to visualize spheres is if you have, infinitely many circles with the same center, right? That makes a sphere, all right? A sphere is the set of all points that are equidistant from a given point called the center. So if from this point I go out 5 meters that way diagonally, and then I go out 5 meters that way, and I go out 5 meters that way, and this way, and this way, and this way, all of those points will create a three-dimensional surface, which is a sphere. Okay. When a plane intersects a sphere so that it contains the center of the sphere, it is called a great circle. So take a look here. You have a sphere, and then you've got a plane. In the first one, it's intersecting the sphere at one point only. Here, it intersects it here. And do you see how the surface that, the plane cuts that sphere is a circle, right? So like if you look at it head on, it'll be a circle. And then if I moved that paper down a little bit, it'll be another circle, but somewhat bigger. Down a little bit, it'll be bigger. And then obviously, if it intersects at the very center, then that's the biggest circle that you'll get, because after that, they'll get smaller again. That is called a great circle. Remember that, because you're often going to have, in the problems, like the area of the great circle is blah, okay? Now, when you cut at the great circle, the radius of that circle is the same as the radius of the of the sphere, right? And also, at that circle, you cut the sphere into two equal spheres, which are called hemispheres. You guys all know that. So if this is a sphere, it's got a radius here. I'll get you in one sec. It's got a radius here. And now if you have a hemisphere, it's obviously going to have the same radius. Okay, yeah. Oh, that's why we wait. Okay. So the surface area of a sphere. So imagine you're giving somebody just a spherical gift. You want to gift wrap it, but you want it to be totally flush, right? Like you don't want any gaps or edges or whatever, how much paper you would need, right? Well, the surface area is 4 pi r squared. Okay? 4 pi r squared. Very similar to area, but that's 4 pi r squared.
I know it's a bad question to ask, but does it get harder? No.
It would be 4 pi times 5 squared. So this is 100 pi, right? Oh, I don't even need a calculator for this, because 3.14 times pi is 316. Yeah, so 314.16 square feet. So here, radius is 4. So surface area is 4 pi 4 squared. This is 64 pi. 201.06 centimeters squared. Okay, now let's talk about a hemisphere. So for the hemisphere, right? Okay, so the formula for the sphere, the surface area for the sphere, is 4 pi r squared.
Can you do that over 2?
Yes. So, yes. So for the hemisphere, surface area is half of that, so 2 pi r squared. But that's only this surface. In order to wrap this, you're also going to wrap the bottom, right? Which means you have an additional circle, which is pi r squared. All right? So it's going to be 2 pi r squared, yes, plus pi r squared. So together, it'll be 3 pi r squared. Okay, so in this case, it's going to be 3 pi 2 squared, 12 pi, which is 37.7 square feet. And if that wasn't the shortest lesson of all, I don't know what was. That was, well, I've recorded 6 minutes, so there we go. So from this, we're going to do the handout for homework and the practice quiz. Quiz is when?